What's the one thing that will kill your diesel faster than anything else? The EPA. I mean, EGTs, exhaust gas temperatures. Or maybe it's oil starvation. It's a toss-up. Well, that ain't good. Turbine inlet temperature, tint. I like to use anti-seize, as you can tell. That was one drop. Grab your screwdriver and your little pecker. Cummins guys like big pipes. Just the tip. DPF, SCR, DEF, and elemental P. It's actually really simple if you don't think about it. You measure EGTs with a pyrometer. I was about to install one on my Duramax, and I thought, let's demystify the topic. I feel like they should have called it an EGT-o-meter. So here's what I'm going to do. I'm going to talk about EGT science. Actual science. Then I'm going to show you proper pyrometer installation, or at least the thermocouple. This is the important part. Then we're going to talk about EGT control. How do you use a pyrometer to help keep your diesel alive? But first, have you ever wondered why gasoline owners talk AFR and diesel owners talk EGT? Simple. AFR is a fraction, and diesel owners only understand whole numbers. Okay, that's a joke. Probably. Obviously, we could use lambda for AFR, but I don't know how they convert that into sheet. It's a mystery to me. But seriously, in a modern gasoline engine, AFR, air-fuel ratio, is monitored and controlled because it has to be. Gasoline engines literally won't operate if the air-fuel ratio gets outside of a very narrow band, about 8:1 to 18:1. So since AFR data is already available and is actually a pretty good surrogate for combustion temperature and exhaust gas temperature, that's the overarching parameter that gets used for gasoline engines. For performance diesel applications, AFR really doesn't matter. It matters to OEMs for emissions purposes, and it can be manipulated with EGR flow or throttle bodies to meet EPA emission standards, but outside of that, it really just doesn't matter. A diesel engine will operate at basically any air-fuel ratio. On a typical street-driven diesel engine, you could see AFRs anywhere from 20:1 to 80:1, depending on the operating conditions. EGT, on the other hand, is a simple, direct measurement of what's going on inside your engine, and it provides whole numbers that even bubbas like me can understand. And that's why for diesels, we talk EGT, not AFR. So on a diesel, a simple pyrometer and a side view mirror to see exhaust smoke are really all you need to understand what's going on under the hood. All right, let's talk EGT science. I put on my science coat. It adds IQ points. I know you all want to know the magic number for the maximum safe EGT, and we'll get to that. But first, I want to dispel a very common misconception about EGTs. Exhaust gas temperature is not combustion gas temperature. That's the misconception. I commonly see comments like this, and I'm going to use a childish voice.
Pistons melt at 1100 degrees, so any EGT over 1100 degrees will eventually melt the pistons.
And that seems like a reasonable statement, because the aluminum alloys used to make pistons do have melting points around 1100 degrees Fahrenheit. But the reality is, it actually gets much hotter than that inside the cylinders. So when you're towing a heavy load up a mountain grade, and your pyrometer says your EGT is 1100 or 1200 degrees Fahrenheit, the peak in-cylinder temperatures can be over 4,000 degrees Fahrenheit for a small portion of the power stroke. That's hot. Real hot. And the average cylinder temperature will be somewhere between the peak cylinder temperature and the exhaust gas temperature. We'll say 1776 Fahrenheit because America. So your piston, cylinder walls, and heads can see temperatures that are 2 to 4 times as high as your EGTs. So why doesn't everything melt and turn to mush? Well, science. Time and heat transfer specifically. That extreme heat is only present for about 30 to 40 degrees of crank rotation. So let me try to explain some of the in-cylinder temperatures associated with the compression and power stroke of a turbocharged diesel engine. These are all assuming about full load. At the bottom of the intake stroke, before the piston starts its up travel on the compression stroke, the charge air coming into the cylinder could be 150, 200 degrees. It really depends on the boost pressure and the ambient temperature. Now on the compression stroke, about 20 degrees before top dead center, that air has been compressed enough to go from 150 degrees to about 1300 degrees Fahrenheit. That's about the time the diesel starts to inject. Now about 25 degrees after top dead center, as the piston starting its travel down on the power stroke, the diesel has ignited, and now the combustion gas temperature in the cylinder is around 4,000 degrees Fahrenheit. Now by the time this piston gets to the bottom dead center, before it starts the exhaust stroke, the combustion gas temperatures have dropped from 4,000 degrees Fahrenheit to 1,200 degrees Fahrenheit. That's your exhaust gas temperature. Much, much lower than your combustion gas temperature. So what causes the difference between combustion gas temperature and exhaust gas temperature? The ideal gas law. The ideal gas law. All it really means is, as the volume of an ideal gas is compressed its pressure and temperature go up. And if that same volume of ideal gas is allowed to expand, its pressure and temperature go down. Compress, more hotter. Expand, less hotter. The same principle that causes this gas to heat up in compression and ignite that diesel causes this gas to cool down in expansion and make torque. I drew a graph. Temperature on this axis, degrees of crank rotation on this axis. This encompasses 360 degrees of crank rotation. That's only half the cycle. Remember, 4-stroke is 2 revolutions of the engine, 720 degrees. It's half that. And it's also not to scale, unfortunately. It's confusing. I apologize. But here's the deal. 150 degrees at bottom dead center. By the time it gets here, 4,000 degrees. And by the time it gets here, 1,200 degrees. So those temperatures that are high enough to melt a piston are only present for about 180 degrees, 25% of the 4-stroke cycle. The temperatures are high enough to actually melt a piston. The other 75% of the time, they're much lower than that, and all that heat is being transferred out to the cylinder walls, or into the oil, or into the head or the valves, and out to the atmosphere. It's just like running your hand over a cigarette lighter. You could run your hand back and forth over this flame all day without issue. But if you stop it, so the surfaces inside the cylinder actually stay relatively cool, between about 300 and 500 degrees Fahrenheit, except for the face of the pistons and the exhaust valves. Exhaust valves actually get pretty near the exhaust gas temperatures, and that's why they're made of really expensive materials like stainless steel, Inconel, or unobtainium. So what's the magic number? What's the maximum safe exhaust gas temperature on your turbo diesel? In general, you can operate any modern turbo diesel engine with EGTs of 1200 degrees Fahrenheit indefinitely. Anything over that, you need to research your specific application. For example, my 2006 Common Rail Cummins truck could produce EGTs of almost 1400 degrees with bone stock tuning. So the OEM must consider 1400 degrees Fahrenheit to be safe for that engine. Maybe. But in contrast, it's not unusual for competition diesel engines to see EGTs well above 1600 degrees Fahrenheit. That's pretty hot. So what actually happens if those EGTs are too high for too long? Well, if you're lucky, you'll only experience a minor issue like a cracked exhaust manifold or cracked turbine housing. Relatively minor-ish. But the first thing to die will likely be the turbocharger. The edges of the turbine wheel will melt. The turbo will go out of balance. Then the bearings will fail and the turbo will start to eat itself. And your engine might actually eat the turbo. Bad day all around. The excess heat and pressure could also overspeed the turbo and cause the turbine wheel or compressor wheel to rupture. And that's what a blown turbo is. You'll know that immediately. The next thing on the hit list are those aluminum pistons. The heat can cause the top of the piston to erode, crack, or deform. That's a real crack. I definitely didn't draw it with a magic marker. Piston erosion can be cumulative and not reveal itself until you've eroded a hole completely through the piston. But hey, if there's a hole through the piston, excess cylinder pressure is no longer an issue. Try to focus on the positives. But if you're lucky, you'll only burn an exhaust valve or drop an exhaust valve seat or crack a manifold or turbine housing. And no, that's not the I just won the lottery kind of luck. It's more like the one-eyed dog named Lucky kind of luck. He's lucky because he's still got one eye. It could always be worse. So now that we're all EGT scientists, let's install some hardware on this Duramax truck. It's just a gauge or a monitor and the associated thermocouple that goes in the exhaust system upstream of the turbo. There are factory installed EGT sensors on late model diesels, but they're generally downstream of the turbo. Generally in close proximity to emissions equipment like the DPF, but that's not the temperature we want. We want turbine inlet temperature. TIT. That's right, I said it. TIT. TIT. Don't get mad at me. I didn't come up with that acronym. Probably. So let's talk about how this pyrometer thing works. It's actually really simple if you don't think about it. You have a thermocouple that sends a signal, voltage, to a gauge or a monitor, and they convert the voltage to a temperature. There are B, C, K, element of P-type thermocouples. This is a K-type thermocouple. All that means is that this thermocouple is made of alumel and chromel and has a maximum rated temperature of 2300 degrees Fahrenheit. Most thermocouples you find in automotive applications are going to be K-type. The way a thermocouple works is this. If you have two dissimilar metals and bring them together at a junction and heat that junction, it creates a voltage in this circuit. This is the junction of two dissimilar metals, as indicated by the two different colored wires here. When you heat that junction, you get a voltage. Your gauge or monitor turns that voltage into a temperature that somebody like me can understand. Hopefully the word thermocouple makes sense now. Thermo, heat, applied to a pair or couple of dissimilar metals. Thermocouple. Science. All right, so now you know what a thermocouple is. Let's talk about where it goes. Because the location of the thermocouple has a huge effect on the EGT reading. When somebody spouts off an EGT on the interweb, they're talking about the pre-turbo temperature or turbine inlet temperature. We discussed TIT earlier. So the thermocouple is going to be installed before the turbine, generally somewhere like here or maybe here, not here. In some applications, it would be much easier to mount the thermocouple in the downpipe after the turbine. But there's a problem with that. Turbine inlet temperature can be 100 to 400 degrees higher than turbine outlet temperature. It all depends on engine speed, load, ambient temperature, and even color of the engine. This constant variation between turbine inlet and turbine outlet temperature means turbine outlet temperature is not a very accurate or reliable way to know how hard the engine is working. So in race applications where the engine's always running on the ragged edge, you'll often see a thermocouple for each cylinder on the engine. But that's really expensive and not needed for street applications. For us, one pre-turbine thermocouple is good enough. And generally, it will be in the cast iron manifold. But it's also possible to mount in an up pipe on a V configuration engine. Whew. I did all the hard work off camera. I got a truck, it's on jack stands, remove the wheel liner. That's probably the hardest part. All right, we got to put a thermocouple in the exhaust manifold. On this Duramax, the best place is the passenger side, right where the manifold goes into the up pipe. So to drill the hole in the manifold, there's a huge debate over what works best. Put grease on your drill bit, use a magnet, use a vacuum. I just do it with the truck running. With the engine running, there's pressure in the exhaust manifold. So while you're drilling the hole, that pressure will blow the shavings out into your eyes instead up into the turbo. And that's a win. Wear safety goggles. In case you're wondering what it sounds like to drill holes with the engine running, there you go. I got 2 holes for 2 sensors, so it's a little louder, but it's not too bad. It smells great. Here's my gear. I have an automatic center punch. I used an 1/8 inch, 1/4 inch, and then size our drill bits, and then an 1/8 inch MPT tap. Big thing here, this is tapered thread on this fitting, 1/8 MPT. You don't want to run the tap all the way in and then go to test fit the fitting. It'll be loose. You want to run the tap in probably halfway and then test fit the fitting. See if it'll thread in far enough. If it won't, back it out, tap it a little more. Sneak up on it. I don't tap the manifold with the engine running. I like to take my time and get this right, so I turn the engine off and just put grease on the tap. You're going to have to insert and remove this tap several times to get the proper taper in the hole. So you're going to have to grease it several times. Don't dip the tap in the grease unless you want to contaminate your grease with cast iron. Stick your finger in the grease, just the tip, and then rub that on the tap. Make sure you use the proper grease. This is for drum brakes, this is for disc brakes. My truck has disc brakes, so I use disc brake grease on the tap. It's the little things that'll get you. All right, I got those fittings ran in. I like to use anti-seize, as you can tell. That was 1 drop. These are tapered fittings. No reason to uggy duggy. These are a simple uggy. Okay, got the thermocouple installed in the fitting. Want to make sure you don't bend this. It even has a sticker on there that says do not bend. Obviously I have a second thermocouple for another application. If you're wondering what the other fitting is for, it's for this contraption. This is going to be a turbine drive pressure or exhaust back pressure sensor. You need that coiled piece of copper to go between the sensor and the manifold, because the manifold gets really, really hot, and that sensor doesn't like hot. There's no flow through this line, so any heat that is generated at the manifold will dissipate through these copper coils before it gets to the sensor. So that way, your sensor gets to live a long life, and that's good because sensors are expensive. I got the thermocouple installed, and I got it routed up top. We can tie it into our monitoring system, and I've got my turbine drive pressure sensor routed up top there somewhere. These are really nice for plumbing and wiring. I like to share this with folks. It's a rare earth magnet with a loop on it for a zip tie to go through. So you can just stick it to the body of the frame, put a zip tie on there, and you're good to go. I'll leave a link to those in the description, but I must warn you, they're not cheap. These are about $1 a pop, but they keep you from having to drill holes in your body or frame, and you can move them around and reuse them as many times as you want. You want to make sure you clean all that anti-seize off before you button things back up. That stuff's like student loan debt. Once it's there, it never goes away. It's fact. Got the fender skirt back in there. We've got our turbine drive pressure gauge wired up. Got our pyrometer wired up. All the wires are ran just underneath the cowl here. I use my little magnetic zip tie thingies on the underside of the cowl to keep the wires all nice and neat. And I got all the excess down under here, out of the way for the most part. Nobody wants to watch me wire, especially me. And we got the gauge pod mounted up here. I'm assuming there's supposed to be a color contrast for aesthetics. And we got the gauge installed. Looks good. Let's take it for a spin and talk about EGT control. All right. I don't have all my gauges set up the way I want them yet. I got the important stuff right here for you to see. EGT, boost, turbine drive pressure. Anyway, let's go for a drive. All right, you're the proud new owner of a pyrometer. Let's talk about how you can keep that needle out of the red zone. Step one, don't modify your truck. That's funny, right? It's probably not gonna happen if you're a diesel guy. There's just too much easy, cheap power to be had to leave well enough alone. So let's start with the easy stuff. Clean your air filter, check for boost leaks, and clean your cooler stack. You know, your radiator, intercooler, all that stuff. People always think their truck's in good working order, but a lot of the time, there's latent issues they don't even know about. Dirty air filter, boost leak, clogged up intercooler or radiator. I am not too proud to say that I've never checked the air cleaner on this truck. I'm not proud that I haven't done it. I'm just not too proud to say that I haven't done it. I'm human. Let's go ahead and check that now. That is a weird looking air filter. Well, a filter exists. It is dirty, but my filter minder says it's okay. I'm just gonna hit the I believe button on this one and keep going. Well, now that we got that out of the way, we can get back to talking about what really matters. And the biggest factor that's gonna affect your EGTs is just running the proper tuning. If you're not tuned and you're having EGT issues, you need to seek some help because you're not tuned and also because you're having EGT issues. You got problems in two areas. So if you don't have selectable tuning, you've only got one tune to choose from, and you're getting high EGTs for your driving situations, you need to get a new tune. Call your tuner, get it fixed. If you're running multiple tunes, like you've got a DSP5 switch, or you've got a Edge, Evolution, CTS3, whatever, choose the weaker tune. And if you're a 12 valve guy, grab your screwdriver and your little pecker and retune. So when I plugged in my CTS3 to the computer this morning, it gave me the option to upgrade it to a Edge, Evolution, I don't know, the CTS3 with the tuning. It was like 230 bucks for tuning, so why not? Oop, we're turning around. Got to train, folks. Got a pretty good hill pulling out of my neighborhood onto the main road. I'm gonna hit it with the 80 horsepower tune and then hit it again with the stock tuning to show you the difference in the EGTs. I don't have a trailer, just a pretty good way to simulate a heavy load. All right, I'm gonna do two side-by-side pulls on this hill and give you a view of the pyrometer side-by-side for both of them. One on the stock tuning and one on the party tune. That didn't prove my point. I expected more smoke and more temperature. Maybe we should try the excursion. Okay, plan B. Let's take the excursion. I know it'll give me some smoke. I know exactly what tuning's in this truck. Well, that's not exactly true. I'm about to hook my laptop up and know exactly what tuning is in this truck. All right, we got the laptop hooked up to the Hydra. We've got modified stock on tune 1 and extreme street on tune 6. I'm thinking tune 6 might give us a little more smoke in EGT than tune 1, but I've been wrong once before. Ain't that right, girl? Nala. Nala. It's my quality assurance technician. It smells like a tractor pull in my driveway. Love it. And she doesn't know what to think right now. She's never been in this truck. It'll be okay. All right, we're gonna start with a modified stock tune, which is pretty far from stock because this truck's got big full force diesel injectors, big KC turbo, big CNC H-pop, jelly bill tuning. The modified stock tuning on this truck is still hotter than a tuned stock 7.3, so it's still gonna make some smoke and some EGTs because, man, big motor. Oh, thanks for the right-of-way, guy. I had it anyway. I'm doing pulls on flat ground today. No reason to go uphill with this truck. It weighs 10,000 pounds as it sits, so no reason to add extra loading to get it to spike the EGT. We're just gonna do some flat ground 0 to 60 pulls with my dog. She's not really much of a rider, I'm gonna be honest with you. Not a very good co-pilot. All right, we're gonna make a pull on the modified stock tuning, see what kind of EGTs we get. I couldn't see, there's a camera in the way. You guys tell me what it was. Let's switch her over to Tune 6, Hot Street, Drag Street Ripper, the hotter tune, Tune 6. I'm gonna turn my second fuel pump on. That's right, dual fuel pumps. When you turn it up to the higher tunes, you need both pumps to keep up. Of course, we got a little traffic jam here. Now we gotta give them a second to pull away so we can get a good pull. Don't want to run over this little old Bronco or that dually. And my dog almost fell on the floor. I'm sure you guys saw there was a lot more smoke and a lot more EGT on that one. If you got EGT issues, turn it back down to Tune 1 like an adult. Are you thoroughly terrified now? She'll never get in this truck again. Now let's move on from tuning, because you're a man, and you're obviously going to leave that tuner set on kill 100% of the time. So let's talk about some ways to mitigate the consequences of your foolish decision. Exhaust system enhancements. If you can increase exhaust flow, you'll lower EGTs. And I bet you're thinking I'm about to say that you need a 5-inch straight pipe, and that you need to delete your DPF, SCR, DEF, and elemental P. Nope. But that will be successful in pissing off your neighbor and Uncle Sam, so why not? But all you generally need is a larger downpipe. That short piece of pipe that drops from your turbine outlet down to the rest of your exhaust is generally the bottleneck in your exhaust system. It's generally a smaller diameter than anything else downstream, but it has to flow a higher volume of exhaust than anything else downstream. Unless you're a Cummins guy. Cummins trucks come from the factory with girthy downpipes. Cummins guys like big pipes. This thing is substantial. So you can skip the 5-inch exhaust and just install a bigger downpipe. Then install the 5-inch exhaust and the 10-inch tip. Here's a freebie, downshift. That's right. If you're towing and having EGT issues, drop the transmission down a gear or two. Stop lugging the engine. It takes a certain amount of horsepower to move a certain load, a certain speed, and a certain amount of time. And horsepower is basically torque times RPM. So you can either make that horsepower with high torque at low RPM or low torque at a higher RPM. And torque is basically cylinder temperature and pressure. So low torque and high RPM means lower EGTs in this scenario. Now here's a controversial one. EGR deletes. What the hell is that? Hummer? A new Hummer? Nice. Contrary to popular belief, if your EGR system has been stolen by a tweaker or recalibrated with a block-off plate, your EGTs could actually be higher than they would be if the EGR system was still intact. The entire purpose of an EGR system is to reduce in-cylinder temperatures and pressures to reduce NOx emissions. It does this by feeding non-combustible exhaust gases back into the intake stream. So if you remove the EGR system, you now have more oxygen in the cylinders for more combustion. And this could cause your EGTs to be higher, probably. And here's the simplest one. Just let off the skinny pedal. Less skinny pedal means less fuel, means lower EGTs. All right, now for the expensive stuff. Bigger, better intercooler. Or if you're an early 12 valve or early 7.3 guy, just add an intercooler, period. Intercoolers can drop the charge air temperature a couple hundred degrees in high horsepower applications. Cooler air in means cooler air out. It's science. Now for the fun one. Better turbo or add a turbo. With heavy tuning, the factory fuel system can overwhelm the tiny factory turbo. So if your switch broke off in Tune 5, consider a turbo upgrade. Or better yet, step up to compounds. Your wife will be very happy with how much quieter that extra turbo made your truck. Probably. Anywho, I hope this was helpful, or at least entertaining. If it was, please consider hitting that like and or subscribe button. If there's something you'd like to see me make a video about, let me know in the comments. Thanks for watching. And as always, stay curious.